Students, in this video lecture we are going to see about perceptron. So first of all, I am GL Karthik, assistant professor, biomedical engineering department. So we will first start with the simple model of neural network, that is the perceptron. Perceptron learning algorithm is the simplest model of neuron that illustrates how a neural network works. The perceptron is a machine learning algorithm developed way back in 1957 by Frank Rosenblatt, and it was first implemented by IBM 704. So you can see the diagram or the structure of perceptron. So there is a neuron, and neuron gets different inputs x1, x2, x3, and each input has its own associated weights w1, w2, w3, and there is a output. So this is the simple model of perceptron. So this is the perceptron formula that we are going to use. So in perceptron, of course, there is the input, that is the x1, x2, x3, and so on, and there is the net y underscore in, and y is the output here, as you can see, and then you need to update weights, bias, and also the difference in weight has to be updated. So starting with net, that is y underscore in, formula is b, that is the bias, plus summation of xi into wi, where xi is the inputs and wi is the weights. And based on y underscore in value, you can fix the output. Y is equal to 1 if y underscore in, that is a net, greater than theta. Here comes theta. Theta is the threshold value. Here we could take the threshold value as 0.2. So threshold value has to be selected based on the application. Okay. Y is equal to 1 if y underscore in is greater than theta, 0 if y underscore in is between minus theta and theta, and minus 1 if y underscore in is less than minus theta. So y is decided based on the values of y underscore in compared with the theta. And for the updation of weights and bias, there are formulae for updating weights, that is wi of new is equal to wi of old plus alpha t xi, b of new is b of old plus alpha t, delta w is target of x1, x2, 1, that is the target that you get it for the input x1, x2, and then bias 1. What is target? Target is the expected outcome. Okay, there is net y underscore in, based on net value compared with theta, you find out what is output, that is y, and then you have the target. Target is what output you expect. So you compare the output with the target in perceptron, right? Till the target becomes equal to the output, you keep on continuing. So this is the process in the perceptron. We will first see an example. We will start with applying perceptron for the AND gate or the AND function. Here we take inputs as binary and targets as bipolar. So input as binary means it will be zeros and ones, and bipolar means 0 is considered as -1 and 1 is considered as +1. That is what is the meaning of binary and bipolar. Okay. Now we will start applying perceptron for the AND function. So first we initialize the alpha, that is the learning rate. We keep learning rate alpha as 1, w1, w2, b is equal to 0, and considering theta as 0.2. And the weight change delta w is target for the input x1, x2, and bias. And the weight change delta w occurs if there is an error, that is if output is not equal to target, then we have to do delta w change, otherwise delta w remains 0. Okay. So in the next video we will see about how we apply perceptron for the AND function with the different inputs of the AND gate, that is for 0 0 0 1 1 0 1 1, right, and 1 0. So different inputs, how you apply the perceptron. Thank you.